Okay, let's try this hyperbola question. And let's see what they've done here. They have done, first question here, they've told you that this is a hyperbola you're looking at. They're telling you that this line here, g, is x minus 3. G of x equals x minus 3. We've got a line here, and it goes right through where these two asymptotes go through. That could be useful. And yeah, it cuts the line at 0 and 1. They give us a point right here. And they tell you that the domain of this function is these two sets, from 1 to negative infinity and from 1 to positive infinity, but it's not a square bracket, so it doesn't include 1. Well, that means that x equals 1 is the axis, is the asymptote. And that means p must be minus 1. So 1 is the thing that you can't, is the place you can't go. And to make that work, p must be minus 1. So 1 minus 1 is 0. That's the place you can't go. So p is minus 1. What's the equation of the horizontal, this line here? Well, we know that it's right, it's given right here. It's 1. I don't need to do it. I can see that it's 1 here. They've kind of given that it looks like that it's cutting at 1. It's cutting at 1 here. So if we put 1 in here, if we put 1 in there, 1 minus 3 into the line, we get minus 2. So that's definitely minus 2. So y equals minus 2 is the horizontal asymptote. What about A? Well, now we've got we know that this is minus 1. We know that Q is minus 2. We've got a formula, and all we do is sub in the points 0 and 1 that they gave us. And that'll be minus 1. We're going to add 2 there. We're going to get 3 equals A divided by negative 1 is minus A. So A must be minus 3. Now we've got the whole formula. We know A is minus 3. Now, for which values is this function going above 0? I can see it's just from here, but I don't know what that point is. But that's the x-intercept. How do we get an x-intercept? We have to make y equals 0. So we add 2 and multiply by x minus 1. We get 2x minus 2. Then we add 2, we get minus 1. And then divide by 2, x must be minus a half. So it looks like right less than 1, or greater than or equal to minus a half. That's your answer for when f gets bigger than 0. That's the only place it gets positive. It's all negative down here and everywhere, all the other values of x. Now, the last question is a little bit tricky, or it makes you think. It says here that f undergoes some kind of transformation, but it's got the same range and the same domain. That means these asymptotes don't change. Well, what would you do? But what happens here? But the derivative is negative instead of positive. You see, if you look here, that the derivative is positive here. The slope, if you make a tangent line anywhere, look, it's going to be pointing uphill. But this one's going to be pointing downhill. Now, how could we take this graph and just turn it into something where everything was downhill? Well, you just sort of have to imagine, what if we turned this 90 degrees? If we took these two graphs, you see that's positive gradient. If we just rotated it about the point, 1 and minus 2, right about the center, if everything rotated, it would turn into this one. So it's only 2 marks, but that's one transformation that would make it true. I would say rotate f at 90 degrees about the point 1 and minus 2. I should have said that right there too. So you rotate it about the point 1 and minus 2. And there you go. That's your answer.